View in performance space with performance acceptance region A and distribution of performance, red, under statistical and operation variations from which WCD can be calculated. Note, often the statistical variables itself are not correlated but the performances do so, ACC. Also often the specifications are set by just upper or lower limits, so being straight lines. If we would plot the statistical variable space, the spec limits would typically become nonlinear shapes. Also in the design phase, engineers already try to maximize the yield by using simulation techniques and statistical models. Often the data follows the well-known bell-shaped normal distribution, and for such distributions there is a simple direct relation between the design margin and the yield. If we express the specification margin in terms of standard deviation sigma, we can immediately calculate yield Y according this specification. The concept of worst-case distance, WCD, extends this simple idea for applying it to more complex problems, like having non-normal distributions, multiple specs, etc. The WCD is a metric originally applied in electronic design for yield optimization and design centering, nowadays also applied as a metric for quantifying electronic system and device robustness. For yield optimization in electronic circuit design, the WCD relates the following yield influencing factors to each other: statistical distribution of design parameters usually based on the used technology, process operating range of operating conditions the design will work in, performance specification for performance parameters. Although the strict mathematical formalism may be complex, in a simple interpretation the WCD is the maximum of all possible I.E. being within the specification limits, performance variances divided by the distance to the performance specification, given that the performance variances are evaluated under the space spanned by the operating range. Note, this interpretation is valid for normal, Gaussian, distributed variables and performances. Luckily the specification margin of a design is almost intuitively related to the yield, E.G. If we have a larger safety margin in our design to the limit, S, we are more on the safe side and the production will contain less fail samples. Actually, the advantage of WCD is that it offers an elegant method to treat also non-normal and multivariate distributions and still offering a pictorial, intuitive understanding.